Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum dear students. Welcome to week number 14, recorded lecture number 37. Well, in today's lecture, we are going to cover ethical problem solving techniques. That is part 1. We will be having part 2 for this ethical problem solving techniques also, and that will be covered in the next lecture inshallah. So let's move forward. Okay, so now let us begin with the concept of ethical dilemmas. Though we have slightly touched them in the previous lectures, but today we would like to discuss them in bit detail. Well, ethical or moral dilemmas are situations in which moral reasons come into conflict, or in which the applications of moral values are unclear and it's not immediately obvious what should be done. So things are unclear. At the first stage, one cannot easily come up with the decision. So the situation is a bit confusing. That's why we call them dilemma. Ethical dilemmas arise in engineering as elsewhere because moral values are many and varied and can make competing claims, because as we have learned that moral values are not limited. Even ethical theories they do not provide us definite solution like scientific theories. So because moral values are varied, they can vary according to context and according to situation. So that's why it becomes more difficult to solve the dilemmas. Yet, although moral dilemmas comprise the most difficult occasions for moral reasoning, they constitute a relatively small percentage of moral choices, that is, decision involving moral values. Well, the vast majority of moral choices are clear cut. Like most of the professional ethical problems, cases that you will come across, most of them are clear cut. An average person or an average engineer can easily solve them, provided he or she has understanding of ethical theories and code of ethics and other such codes. Although we sometimes fail to accept responsibly, it's actually act. Although we sometimes fail to act responsibly, because of negligence and weakness of will. So sometimes the case is not that much difficult, but it's our failure of responsibility and negligence that we are unable to reach the right decision in that particular case. Now we shall be moving towards a case study in which we will try to understand how difficult and how complicated these dilemmas can be and how vigilant an engineer has to remain in professional life. And it's a sort of complicated case study that developed over years. It was not a year or two, rather maybe even a decade or more than that. So we are going to discuss this case, designing aluminum cans. I'll be reading the whole case first, though it's a bit long, but unless we understand the case itself, we will not be able to understand the decisions that are made about that case. So, since it is important to understand the case, so I've placed the whole case here and I'll be reading it for you. When and if required, I'll also go for its explanation. So, designing aluminum cans. Henry Petroski chronicles the development of aluminum beverage cans with stay on tab openers. Uh, of course, you must have had those beverages like Pepsi, Coke, or other such beverages in the cans. And if you take their lid, that is, place at the top, and we do not require an opener for it, so we can open it with our finger, and the remaining part can stay attached to that opener. So the case is about that. Aluminum cans are now ubiquitous. Approximately 100 billion are produced in the United States only in each year. So only in United States. The figure is not for the whole world, it's only for the United States. The first aluminum can was designed in 1958 by Kaiser Aluminum in the attempt to improve on heavier and more expensive tin cans. See, we are going back to 1958. Since then, even today, we have this problem sometimes, though it has been improved. So we can say this case consists of almost 60-70 years. Well, aluminum proved ideal as a lightweight, flexible material that allowed manufacturing of the bottom and sides of the can from a single sheet, leaving the top to be added after the can was filled. So within one sheet they would cover bottom and sides, and then they would keep the mouth open once they would fill the beverage. After that they would cover the top, so the top was then separately placed. The trick was to make the can strong enough to keep the pressurized liquid inside while being thin enough to be cost effective. So there were two main purposes. One, it should be strong enough that it could keep that pressurized liquid, like these beverages are pressurized. If you just open them hard, they would just flow out because there is something in them that builds pressure. So one, so that they could keep that pressurized liquid, and secondly, of course, from business perspective, that it should also be cost effective. It shouldn't be very expensive. So if they would use a thicker sheet to make that beverage can, that could cost them a lot. The can also had to fit conveniently in the hand and reliably satisfy customers' need. Yes, customers' convenience also, it shouldn't be too big that customer cannot hold in hand. So that was also kept in mind. See, these are all factors that are needed to be kept in mind while working on some project, in this case like this aluminum can. Design calculations solve the problems of suitable thickness of material, but improvements came gradually in shaping the inward dished bottom to improve stability when the can is set down, as well as to provide some flexibility for expansion of the can. So these all changes, the bottom and flexibility, they were gradual changes, and initially they were not there, but as they did more research on it, or maybe they took more feedback from experts and from customers, so they made these changes accordingly then. The first aluminum cans, like the tin cans before them, were opened with a separate opener, which required additional manufacturing costs to make them readily available to the consumers. Yes, at the initial stage, like uh, for regular bottles, we require an opener, not the plastic one. So we require a regular bottle. For regular bottle, we require an opener. Similarly, for cans in the initial stage, they would require an opener that could be used to open the can, and of course that opener would also cost something, and again it was less convenient for customers to carry the openers everywhere with them. The need of separate openers also caused inconvenience, as Ermel Fraisse discovered when forgetting an opener while on a picnic in 1959. He had to resort to using a car bumper. Like, he was on a picnic and forgot the opener, they could not bring, so ultimately he had to use a car bumper. So that was a problem identified by someone, because that person, that consumer, Fraisse, who owned Dayton Reliable Tools and Manufacturing Company and was hence familiar with the metal, envisioned a design for a small lever that was attached to the can, but which was removed as the can opened. The idea proved workable and was quickly embraced by the manufacturer. The person was familiar with the tool and manufacturing because he owned a company, so he came up with the idea that why not add a lid on this can that can be removed without an opener and can be detached, can be separated from the can, and of course that was profitable for the manufacturers also, because they wouldn't have a separate opener, and their consumers could easily open it anywhere. So it was the idea was taken up by the manufacturers. Well, gradual improvements were made over subsequent years to ensure easy opening and prevention of lip and nose injuries from the sharp edges of the opening. So this idea remained there, it was accepted, and the new cans were made with detachable lid, but the problem was that the lid that was detached, its sides in the beginning were very sharp, and usually they would injure the consumer, like if while someone would be taking, so sometimes the lips would get injured because of that sharp edges, and other times maybe if it touched the nose, then nose would get injured. So one problem was solved, that they didn't require a separate opener, but at the same time the second problem came, that the consumer would get injured, though the injuries were minor, but anyhow they were injuries. So after that, within a decade, an unanticipated crisis arose, however, creating an ethical dilemma. Frase had not thought through the implications of billions of discarded pull tabs causing pollution, foot injuries, and harm to fish and infants who ingested them. Now, see, when Frase in 1959 came up with the idea, so he saw only technical side, and the technical side was that if a detachable lid can be placed on the can, so we won't require an opener, because he faced the problem himself on the picnic. So but he ignored many ethical problems. After decades, the ethical dilemma came up, that Frase had not thought through the implications of billions of discarded pull tabs causing pollution. So, of course, billions of cans were produced. So, billions of pull tabs, those detachable or removable lids of the can, they are being called pull tabs. So, they were causing pollution. People would, detach them and throw them anywhere. Foot injuries, like on beaches and such places where people would like to walk without shoes or sandal barefooted. So if the pull tabs were there, they would get injured, and they also harm the fish and infants, in multiple ways. The dilemma was what to do to balance usefulness to consumers with protection of the environment. Now, what was the dilemma? That on one hand, the product, the can, had to be useful for consumers, but on the other hand, protection of environment could also not be ignored. Like the moral or sensible people cannot let things happen which are harmful for others, like this is small pull tabs. If they are lying around, they are harmful for environment, they are harmful for people, they are harmful for animals, because they would get injured. So this was the dilemma in this case. A technological innovation solved the dilemma in a manner that integrated all the relevant values. Again, when there is a moral or ethical dilemma, then relevant people in that field try to overcome that, right? We cannot stop manufacturing cans because they are harmful, but we have to find a solution, that what should be done to maximize the benefit and to reduce or limit the harmful effects of that particular case. In 1976, Daniel F. Kudzik invented a simple stay attached opener of the sort we are familiar today. Like today, when we use this beverages can and we open it, so the lid can stay attached to it. There is no need to remove it altogether. Rather, you can use a straw and you can pass it through that handle of that detachable lid. So Daniel came up with that okay, now this lid won't get removed, and so obviously the problems that were previously, because of the lids, they could be reduced, or even they could be completely finished. Once again, minor design improvements came as problems were identified. So now the problems were identified by by the people, or maybe by consumers, or the experts, and then minor design changes were made, so the problem was resolved. Now they would not find the scattered pull tabs or scattered lids of the cans around, because they could stay attached to the cans. Well, indeed, the search for improvements continues today, because people with arthritic fingers or long and breakable fingernails have difficulty using the current openers. So, despite this development of can has gone through almost 60 years development, even today the problem exists. And the problem today is that those people who have arthritic fingers, and they find it difficult to open it, and it can harm them, or the people who have long fingernails and they are breakable, so if they push it hard, they can have their nails broken. So still these two types of clients or customers find it difficult to use the product. So maybe they are now thinking on how to overcome this problem as well. All the while, of course, the broader problem of pollution from cans themselves promoted recycling programs that now recycle more than 6 out of 10 cans. Of course, this is still leaving room for further improvement here as well. Now, it after having solved those pull tabs or lids for the cans, the other problem was what to do with all those cans, so millions of cans, so would be thrown away, and again they would cause environmental pollution. So the solution for that was that they could be recycled. So out of every 10 cans that were consumed, 6 of them could be recycled. But again, as the case states, that this needs to be improved, so that out of 10, maybe all 10 of them are recycled, so that there is lesser pollution in the world. Petrosky recounts these developments to illustrate how engineering processes by learning from design failure, that is, designs that cause unacceptable risks or to other people. Now, see, we can see by having a look at this case that how engineering processes improve through the failures. Like, they have some lacking, and then they improve, and then they move forward. But another thing that is to be noticed, that engineers also have to keep the moral side of the project in mind while working on a project. Like in this case, the injuries and all that. At each stage of the design process, engineers are preoccupied with what might go wrong. The hope is to anticipate and prevent failures, drawing on knowledge about past failures, of course. The idea is, if you are working on a project, if there was some past failure, some problems occurred, so you do not ignore them, and considering those past problems, you try to resolve them and move forward. Here, however, our interest is in how moral values were embedded in the design process at all stages, in addition to surfacing in explicit ethical dilemmas concerning the environment. Of course, that this is a technical case also, but actually our focus in this case is from moral or ethical perspective, that how these moral and ethical values were ignored. Now, if we understand moral choices broadly as decisions involving moral values, then the development of aluminum cans can be understood as a series of routine moral choices interspread with occasional moral dilemmas. So we can see now this case as a series of moral problems. Let's move forward and see them. Moral values entered implicitly into the decision making process of engineers and their managers. Decisions that probably appeared to be purely technical or purely economical. Now we see, even in this case, these decisions like making a can apparently were that okay, technical, it should be lighter and it should be stronger, and economical, that it should be less. But at the same time, there were embedded many moral values that were kept in mind, like it shouldn't be harmful for the people. Then when it was ignored, then it injured people lips and noses, and even it caused foot injuries. They should also have been considered while working on technical side and financial side of these cans. Well, this appearance is misleading, for the technical and economic decisions had moral dimensions in four general directions. There were four general directions that should have been kept in mind while developing these beverages cans. Number one, safety should have been kept in mind. Number two, environmental protection should have been considered. Number three, consumer usefulness is to be targeted. And the last one, economic benefit. Of course, because this is case of a commercial organization, then the profit that they would earn from that product. So these all four dimensions should have been kept in mind. Now let's see these four dimensions. First, human safety is obviously a moral value rooted directly in the moral worth of human beings. Some aspects of safety seem minor, like slight cuts to the lips and noses from poorly designed openers, and minor injuries to feet in recreation areas such as beaches. So they seem minor, but minor injuries might cause infections, and even by themselves they have some moral significance. So apparently they seem minor, but they can cause infection, which can be a bigger problem. Again, various kinds of poisoning might occur unless the material were tested under a range of conditions. That material could have caused some poisonous effects, and there are potential industrial accidents during the manufacturing process. During the manufacturing there can be many accidents, and those accidents could have caused harm to the workers involved in manufacturing. Finally, extensive testing was needed to ensure that exploding cans, although not inherently dangerous, did not cause automobile accidents when drivers were distracted while opening cans. So they said, well, this should have also been kept in mind, that if someone opens the can on road, and the driver may get distracted with its noise, and that could cause some sort of an accident. A second set of moral values concern the environment. First was safety, now second is environment. Many of these values overlap with the first set, safety. Billions of detached can openers raise the level of hazards to people walking with bare feet. Injuries to fish and other wildlife posed additional concern. So, though this was also covered in safety, but this is also part of environment. Depending on one's environmental ethics, injuries to wildlife might be understood as direct moral harms to creatures recognized as having inherent worth, or instead an indirect harm to human being. Well, if these creatures are lost, then indirectly human is at lost, like the fish, because human beings use fish or other animals. The broader problem of environmental pollution from aluminum cans and their openers required corporate action in paying for recycled materials, community action in developing the technologies for recycling, and changes in public policy and social attitude about recycling. So, this recycling step was part of environmental protection, so that all these used leftover cans and their lids, they do not harm environment. So the decision of recycling was basically addressing the environmental issues. Now the third, some moral values are masked under terms such as useful and convenient product, right? We tend to think of such matters as normal, especially with regard to trivial things such as sipping a carbonated beverage with a pleasing taste, but there are moral connections, however indirect or minor. So, what are the moral connections? After all, water is a basic need, and convenient access to pleasant tasting liquids contributes to human well being. However, slightly these pleasures bear on human happiness as well being, especially when considered on the scale of mass produced products. Apparently, these are for the pleasure of the human being, but when these like in this case, these products were manufactured in large number, like they were mass production, then this that was for human pleasure or happiness can also be harmful for the human. In addition, the aesthetic values pertaining to the shape and appearance of can have some relevance to satisfying human desire. Well, fine, we can use it. It can be okay. We say, okay, it looks good when it is with this size and with this color. These are aesthetic values and pleasing the human. But of course, the danger cannot be taken for the aesthetic values only. Now, finally, the economic benefits to stakeholders in the corporations have moral implications. So they don't just have to see that they are making a lot of money, so they also have to see moral side. Money matters, and it matters morally. Jobs provide the living for workers and their families that make possible the material goods that contribute to happiness and survival. The corporation's success contributes as well to the income of suppliers and retailers as well as to stakeholders. So that is also important, that it's not only the manufacturer who is going to get benefit, that manufacturing is going to give jobs to the people and jobs to everyone, but that does not mean that for economic benefit moral values should be left. So all these values, safety, environmental protection, convenience and money, were relevant throughout the development of aluminum cans, not merely when they explicitly entered into the moral dilemma. So these all points, safety, environment, protection, convenience and money, they should have been kept in mind since the beginning when the can development started. So and they shouldn't have waited for the problems to occur and then it should be improved. Though we cannot say that a project is 100% and it does not have any moral issue or technical issue. Those minor issues may come as the product develops, but the engineers and other development team must do their level best to see all aspects of the product, like safety, environment, protection, convenience and of course money. Hence the case illustrates how moral values permeate engineering practices, how moral values are integral part of engineering practices. So while making a project, an engineer has to take care of moral values, and for that he or she has to understand what is moral value, and he or she has to understand the moral theories and moral codes that we shall be covering in the next slide. So thank you very much for today, and inshallah see you in the next lecture. So